This time on Battle Factory. Carried to safety on a bed of shock-absorbing springs. A medal that commemorates supreme sacrifice. Jumping out of a plane when the drop zone is a combat zone. And a lightweight fighting vehicle gears up with heavy firepower. Battle Factory steps beyond the front lines into top secret factories where combat gear is built for battle. Stitching these sheets of lightweight material together can create an air-resistant canopy that can drop a fighting force out of the sky and turn the tides of war. When Leonardo da Vinci first conceived of the parachute in 1483, he may not have realized the impact it would have on warfare. 5 centuries later, the Allies launched Operation Varsity. On a single day in March 1945, 16,000 British and American infantry were dropped onto the eastern banks of the Rhine, securing strategic towns and bridges and playing a pivotal role in the Allied victory. The RS-2000 military parachute breaks down to the chute pack, the harness, and the canopy. It takes 90 meters of tear-resistant material to create the parachute canopy. The idea of a parachute is simple. A canopy traps a large volume of air, creating enough resistance to dramatically reduce your terminal velocity. So you can jump out of a plane and land softly on the ground. But the design of a parachute is actually quite complex. The RS-2000 is made of 2 types of nylon, airtight and porous, which lets some of the air through. Hundreds of individual panels of both fabrics are laid out, measured, and machine cut on a diagonal. This prevents any rips or holes that might occur from spreading while in use. The panels are sewn together into 7-meter wedges. The combination of airtight and porous panels help to soften the tug of the canopy opening and stabilize it during descent. Nylon tape is used to ensure the seams are tight. A rip in the air could prove fatal. Then they are laid across a light table. Every seam is meticulously checked to make sure they overlap perfectly and will hold under pressure. The wedges are sewn together and the seams are checked again. It takes 30 of them to create the parachute canopy. A circular vent is left open at the top of the parachute. This vent prevents the canopy from opening too fast and too hard and jerking on the harness with a painful jolt. The suspension lines are what connect the canopy to the jumper's harness. Each parachute requires 30 lines, which are cut into 9-meter lengths and pinned into place. Then, they're sewn into the parachute's nylon seams. Once the parachute is complete, it's blown open with compressed air. Every seam and fitting is inspected before the canopy is folded up and put inside the chute pack for deployment. The harness is what suspends the jumper from the canopy. It's made from very strong nylon strapping that is measured and cut with a heat knife to prevent the ends from fraying. The strapping is secured together with a series of buckles and clips to make an adjustable harness that loops around the shoulders and legs. On an airborne mission, paratroopers typically jump from low altitudes to minimize exposure to enemy gunfire. For safety and simplicity, the chute opens automatically moments after the jumper leaves the plane. A 4.5-meter yellow static line runs from the cable on the plane to the jumper's chute pack. When he drops past 4.5 meters, The static line opens the pack and frees the canopy. Next time this chute sees daylight, it could be a kilometer above the ground, and every paratrooper who steps out of a plane is taking a leap of faith that his chute is going to let him down easy. Coming up on Battle Factory, a stretcher that suspends the victim in comfort and security, and a medal to honor those who gave everything in service of their country. These simple springs aren't just designed for a pleasant ride. The Yellow Jacket basket's unique shock-absorbing suspension will protect a victim who's already in trouble from further injury. In search and rescue, getting the victim swiftly and safely to medical attention is critical. But sometimes the stretcher, which consists of 2 poles and a piece of canvas, does more harm than good. Now, the Yellow Jacket is the paramedics' answer to an age-old problem. The stretcher breaks down into the shell, the springs of the insert, and the frame. The first step in building the frame is to measure out lightweight aluminum tubes. It takes 41 precision-cut pieces to construct the stretcher frame. Each piece is bent into shape on a digital pipe bender. Every angle is programmed into the press so that every piece fits together. Then, the 2 largest rods are hammered together to make up the outside edge. Next, it's placed on a jig, an adjustable device that locks all the pieces in place so they don't budge while being welded. Once everything is locked down, the frame is welded together. The yellow basket was inspired by a rescue gone wrong. A construction worker had fallen into a deep pit and broken his leg. Firefighter Ian Bassendale was among the first responders to haul the victim out. They eased him into a conventional stretcher and strapped him in with ropes. On the way up, the victim slipped, causing a simple fracture to become a painful compound fracture. Bassendale vowed to build a stretcher that would keep a patient secure and safe, no matter how steep the rescue. The shell is a lightweight innovation that keeps the patient secure at any angle. The super tough plastic can withstand extreme cold and heat and can take a beating being dragged over rocks and snow. Holes are cut into the pre-made shell so that it'll fit snugly onto the frame. The stretcher bed is cut from extremely durable nylon reinforced vinyl. The pieces are stitched together using tough nylon thread. The innovative belt system is designed so the victim can be transported securely at any angle. And each of the belts is tested to 5,000 pounds. So once you're buckled in, you're not going anywhere. Before the yellow basket, it took 45 minutes of lashing with rope to prep a victim for an aerial rescue. Now it takes just minutes to secure the passenger for an airlift. The spring system is what gives the stretcher its unique shock-absorbing capacity, and the difference between a safe ride and a potentially damaging one. 10 individual springs secure the bed to the aluminum frame. The springs are distributed around the frame to maximize shock absorption, doubling up at the head and hip area, where the patient is heaviest, and most likely to be hurt. The stretcher can take the weight and take the hit. Finally, the stretcher is then lowered onto the shell and clipped into place. The Yellow Jacket stretcher has revolutionized the rescue process for over 5,000 first response agencies and military organizations around the world, ensuring that the trip to safety is a success. Coming up on Battle Factory, awarding the highest honor for the greatest loss, and the business end of the Stryker armored vehicle. These 1,000-ounce bars of pure silver bullion can be worth tens of thousands of dollars apiece. So one pallet alone can be worth over $1 million. But some of Canada's bravest have paid a much higher price. The Sacrifice Medal was created in 2008. And today it's been awarded to 780 Canadians wounded or killed in the service of their country. In Afghanistan in 2007, a deadly IED blast wounded a young soldier named Simon Mayou. As a result, his left leg had to be amputated. 2 years later, Simon was awarded the Sacrifice Medal and became the first Canadian amputee to be returned to active duty. He flew out the very same night as his medal ceremony. The medal is manufactured at the Royal Canadian Mint in Canada's capital city, Ottawa. Over $1 billion worth of precious metal is stockpiled here. So armed guards and closed-circuit cameras track every movement inside the mint. From the metal design to engraving the die, creating the Sacrifice Medal requires skill and care. The Sacrifice Medal breaks down into the ribbon, the suspension, and the medal. Using a design approved by the Queen in 2008, the front side of the 3.5-centimeter disc is engraved with the image of Queen Elizabeth II, the head of state and the armed forces. On the reverse is the statue Canada from the Vimy Ridge Memorial, the symbolic mother of a nation grieving for her fallen. The digital image is transferred onto a steel die and used to strike the Sacrifice Medal. The bars of fine silver that will make up the medal are lined up in a conveyor belt and carried into a machine that cuts them into thirds so they'll fit into the casting furnace. Then they're hand-fed into the furnace, which reaches 1,250 degrees Celsius, in order to turn the precious metal to molten silver. The silver comes out in water-cooled slabs, about 13 centimeters wide and various thicknesses. Then, the shiny strip is wound into 450-kilogram coils, about 2.4 meters long. In the rolling room, the coil is unspooled and rocked back and forth to thin out the slab to a higher gauge. To keep the silver soft, it's reheated in another furnace at 500 degrees. It's put back on the roller, and finally the silver strip is thin enough for the basic shape of the metal to be punched out. A blank is then prepped for striking. It's blown clean and placed in the press. During the striking process, the die strikes the design onto both sides of the silver disc with several hundred tons of pressure. Once the metal is struck, it goes into a mill where the edges are shaved smooth. A hole is drilled in the bracket, and the suspension, which will hold the ribbon, is attached. Before being awarded, the medal is suspended on a multicolored ribbon. The red stripe is symbolic of spilt blood, the black symbolizes loss, and the white stripe represents hope and peace. For soldier Simon Mayeux, going back to the battlefield didn't just take courage. He had to prove he'd overcome his disability, marching 14 kilometers on his artificial limb, digging a foot-deep trench, and carrying a fellow officer for 100 meters. Soldiers like Mayeux, those who made it back, those who didn't, are emblematic of the bravery, the service, and the sacrifice that merit the Sacrifice Medal. Coming up on Battle Factory, 1 cannon, 4 kinds of ammo, and a round every 6 seconds. This tube of forged steel will be hammered into one of the most powerful and famous cannons in modern warfare. Today, the M68 105mm cannon sits on the turret of a Stryker armored vehicle. But it's a cannon with a long and storied history. During the Gulf War, the 105 was mounted on the turret of a Patton M60 battle tank. In February 1991, the 1st Marine Division spearheaded the liberation of Kuwait. It looked like the advance would be uncontested until the Iraqis attempted a daring counterattack. The Americans, in Patton M60 tanks armed with 105mm cannons, were forced to go head-to-head against hundreds of Saddam's tanks and armored vehicles. Over 20 years later, this cannon is still a force to be reckoned with. A battle tank is only as effective as its gun, and for the Stryker vehicle, that's the M68 105mm cannon. First, a block of gun steel is heated in a furnace for an hour at 2,000 degrees to soften the metal. Then, a jaw-like mechanism called a chuck grabs the tube and pushes it into the rotary forge. In the forge, 4 synchronized hammers strike the tube with 200 tons of force. As the hammers pound at its surface, the tube rotates. This process lengthens and shapes the red-hot metal as if it were clay. Coming out of the forge, the cannon has stretched in length from 3.3 meters to 6.8 meters. The cannon is lifted onto cooling racks to cool for 24 hours. Then the cannon is reheated in another oven with open flame for about an hour and then cooled with water. This process hardens the steel. After all this heating and cooling, the cannon develops bends. A shell launched from a warp cannon will veer off its target and might even misfire. To straighten the cannon, it's hoisted onto a vertical press. The tube revolves while a probe measures it and the operator marks any warps. Next, 1,000 tons of pressure is applied to the areas that are warped, and the cannon is made perfectly straight. During the Gulf War liberation of Kuwait, Saddam's tank units launched a fierce attack against the U.S. troops. They responded with force. The Patton M60 was a superior tank, and the 105mm cannon meant the Americans could get shots off from 2 kilometers away, outgunning the Russian-supplied T-64s. Hours later, the Iraqi arsenal lay in ruins, while the Americans didn't suffer a single loss. This marked the end of Saddam's occupation of Kuwait and the beginning of its liberation. First, the cannon spends 6 hours rotating on a lathe. It machines off the rough exterior metal called bark, leaving behind a shiny, clean finish. Next, a machine drills through the length of it to make the inside opening of the barrel wider. Then, it is honed by rotating grinding stones inside the cavity to smooth it out and bring the barrel close to size. Synthetic oil reduces the extreme heat and friction. When it's finished, the diameter will be exactly 105 millimeters, the measurement that gives this cannon its name. Once the inside has been smoothed out, the cannon barrel is checked for cracks and imperfections. The interior is brought to spec, and the breech end of the cannon is threaded so it can be attached to the tank. Finally, the cannon is rifled. Helical grooves are carved onto the inside walls of the barrel, which causes the shell to spin when it fires. This stabilizes its trajectory and improves the aim. By the mid-1980s, the 105 millimeter cannon ceased to be the largest tank cannon out there when the M1 Abrams was built. But the 105 is still a force to be reckoned with. These days, it does duty on the top of a Striker, an armored fighting vehicle. And with the 105 millimeter cannon riding up top, it now wields the power of a battle tank.